Good morning, all. Myself, Kalaichilvi, working as Assistant Professor, Selection Grade 1 in the Department of Computer Science and Engineering at Erode Sengundra Engineering College. In today's video, we are going to discuss about the topic Quine Mc-Cluskey method. It is the other method for simplification of Boolean function. In previous method, we have discussed the simplification of Boolean function method as Karnoff-Mapp method. In this video, we are going to discuss the second method, which is called the Quine Mc-Cluskey method, otherwise called as tabular method. Quine Mc-Cluskey method, a systematic simplification procedure to reduce a min-term expansion to a minimum sum of products. Use xy plus xy dash equal to x. So in this, y plus y dash becomes 1 and the remaining term we are getting is x. This is to eliminate as many as literals as possible. The resulting term which we are getting is the prime implicants. Use a prime implicant chart to select a minimum set of prime implicants. We have to draw a prime implicant chart so that we can able to get the minimized Boolean function, or otherwise said to be the minimum set of prime implicants. Determination of prime implicants. Eliminate literals. How can we eliminate literals? So two terms can be combined if they differ in exactly one variable. So consider these two terms, a b dash c d dash and a b dash c d. So in this, d dash and d differs. So if we are considering this as a variable, this may be somewhat complex to identify the different terms. So we can consider as zeros and ones. So this a b dash c d dash can be considered as 1010 because a is a true variable, or it is a true literal, it is 1. B dash is a complement literal, it is 0. Again, c is a true, it is 1. D dash is complement, it is 0. And here a b dash c d is considered as 1011. So in this, the different term is for first three variables, it is 3 literals. It is for the variables a b c is 101. Here also it is 101. For d it is 0 and it is 1. For the first term d is 0 and for the second term d is 1. So it differs by one variable. So we can get the resultant term as product term as a b dash c 101. So we are going to consider the variable which is differ by only at only one position. In this method we have to consider this as the main point, which helps in simplifying the Boolean function. So here we can consider these two terms, a dash b c dash d plus a dash b c d dash. So this cannot be combined because when writing with zeros and ones, it is 0101 and it is 0110. Here first two literals are same, 01. For the third one, for the variable c, here it is 0 and in the second term it is 1. And for d also, the first term is represented as 1 and in the second term it is represented as 0. So in this, the number of variables differs. The number of variables differs or 2. So we should not compare these two things. So we have to compare wherever that there is a possibility of change in only one bit position, that have to be compared in such a way that we have to proceed to find the simplification of Boolean functions. So we need to compare and combine whenever possible. Sorting to reduce comparisons. So first we have to sort the given in the question, and that have to be arranged with respect to the number of ones, so that we are saying it as a sorting the minterms. So sort into groups according to the number of ones. So we have to group the minterms with respect to the number of ones. So here is an example. We are considering f of ABCD equal to summation of 0, 1, 2, 5, 6, 7, 8, 9, 10, 14. So in this, 0 can be represented as it is a 4 variable Boolean function. 0 is represented as 4 zeros, and for 1 it is represented as 0001. For 2 it is represented as 0010, and for 5 it is 0101. So in such a way that we have to write the binary designators for all the minterms given, and we have to group the minterms with respect to the number of ones. So in the first group, that is the group 0 is considered as or minterm 0. In this, no no one is here, so it is considered as a group 0. And next to group 1, group 1 is that minterm which are having number of ones. So 1, 2, 8 are the minterms which consist of only 1 in the binary designator. So these three minterms are grouped as group 1, and group 2 is considered as number of uh, number of ones is 2. The minterm consists of two ones. So that is considered as next group. And in group 3, for group 3, the number of threes should be 3. So here we are considering the minterm 7 and 14. 7 and 14 are considered as group 3 because 7 is represented as 0, 111, and 14 is represented as 1110. So these two minterms consist of 3 ones. So in such a way that we have to group the minterms. Then with respect to the number of ones, we have to group the minterms. And no need for comparisons where we don't want to compare terms in non-adjacent groups, terms in the same group. So actually, after writing these minterms with respect to the number of ones, we have to compare the groups. The adjacent groups have to be compared. There is no need of comparison uh, comparison of minterms that are non-adjacent and in the same group. So non-adjacent groups should not be compared, and the minterms in the same group should not be compared. The only rule is we have to compare the minterms with adjacent groups. So group 0 can be compared with group 1, and group 1 can be compared with group 2. Group 2 can be compared with group 3. Group 0 should not be compared with group 2, or group 1 should not be compared with group 3. This is not a rule here. So we have to compare the adjacent groups. Comparison of adjacent groups. So use x plus x is equal to 1 repeatedly between adjacent groups. So we have to compare the adjacent groups, those combined or checked off. Combine terms that have the same dashes and differ one in the number of ones. So we have to compare the groups with respect to the different position. That is, the number of ones should be differ in only one position, and that should be considered for this column 2. And in column 3, the same rule which we are following in column 2 have to be considered. That is, differs by only one bit position. The adjacent groups have to be differ by only one bit position. In addition to that, group have to be that is in here we are having the dash here, so that should be considered as the same dash. That dash should be occur in the same position. With that same position dashes, that should be the difference in only one bit position, in such a way that the column 3 have to be filled. See here, so we are considering the example which we discussed in the previous. We are considering the Boolean function in the previous slide. So that is a group. That is the minterm 0, 1, 2, 8, 5, 6, 9, 10, 7, and 14. So this is the binary designators are represented, and this is considered as the column 1, and column 2 is said to be the first level reduction. Column 2 is said to be the first level reduction. In this, we are comparing the adjacent groups, and there should be change in only one bit position. Consider here 0 and 1, min term 0 and 1 are combined, so that here is the difference in only one bit position. Here is 0, here is 1, and all the remaining are 0. So there is a change in only one bit position. So we can consider, or we can group the min term 0 and 1. So here it is grouped, and while writing the combination, that is the group min terms in column 2, so we have to write the same bits as it is, and the differ bit as hyphen. So here the fourth bit position is for 0 it is 0, and for 1 it is 1. So it is differ by the fourth bit. So that fourth bit is represented as hyphen here. All the remaining first bit, second bit, third bit is considered as it is 0. Okay, and we have to uh, go in the same procedure by considering there should be a difference in only one bit position, so that the adjacent min terms have to be grouped. Adjacent group min terms have to be grouped together. Okay, so here 0 and 2 can be combined, so that there is a change in only one bit position. So while writing here 0 comma 2, we can write it as 0 0 hyphen 0, because the third bit position is differs. Third bit position differs. Here is 0, here is 1. If there is a difference in a bit position, that can be represented as hyphen, and the remaining have to be considered as it is. And in same way 0 comma 8, 0 and 8 are differ by first bit position. So this first bit position is represented as hyphen, and the remaining are considered as it is 0. Okay, so in this way the first two adjacent groups have been combined, so that the group 0 and group 1 comparison is over. And next, moving on to the comparison with group 1 and 2, there is a possibility of combining the min term 1 and 5. So for 1 and 5, there is a change in second bit position, so that can be represented as hyphen, and first bit position is 0, both are same 0, and second bit position there is a change, so it is represented as hyphen, and third bit is 0, it is written as 0, and for fourth bit it is for min term 1 and min term 5 it is 1, both are 1, so it is represented as 1. And similarly we can combine the min term 1 comma 9. And for what about for 1 comma 6? 1 comma 6, for first bit it is 0, here also 0, and for second bit is 0, here is 1, and for third bit here is 0, here is 1, and fourth bit here is 1 and here is 0. So except the first bit, all the remaining 3 bits are differs, so it is not possible to combine the min terms 1 and 6, so it is not grouped here, right? And for 1 and 9 it is grouped, it differs by only one bit position, and for 2 and 10 it differs by only one bit position, and for 8 and 10 it differs by only one bit position. Okay, so in such a way that we have combined the next two groups. Okay, and moving on to the comparison of group 2 and group 3, we have to check with the adjacent group min terms. So 5 and 7 it is compared, 6 and 7 it is compared. So we have to combine the group, where the difference is in only one bit position. Okay, so this in this way the column 2 have been completed. Column 2 is said to be the first level reduction. Column 2 has been said to be the first level reduction, and column 3 is said to be the second level reduction. So this second level reduction is uh, comparing the adjacent groups in first level reduction. Okay, so here also we have to follow the same procedure. Here 0 1 and 8 9 are combined. So in what way it is combined? 0 1 and 8 9, So this differs by first bit position, and second bit positions are same, third bit positions are also same, and fourth bit position is hyphen. Here also hyphen, here also hyphen. So we have to combine the adjacent groups of first level reduction. That is, here it is represented as column 2. So the adjacent groups of column 2 have to be compared, and that have to be considered in column 3, that is in second level reduction. So in what way we are considering? The hyphen should occurs at same position, and other than that there should be a only one bit position, one difference in only one bit position. Okay, the hyphen should occurs at the same position. After that there should be a one bit position difference. So here 0189 is occurred here. So hyphen 00 hyphen. Okay, so if you are writing 0189, then automatically we can consider the next combination as 0819. 0819, it compulsorily occurs. If it not occurs like that, then may be a mistake in our combination. So if you are finding a one combination, one comparison, that is 01 and 89 is formed, means then automatically we can go with the alternate combination of terms, that is 0819. Compulsorily that should occurs. If it is not occurring, then we can conclude that there may be a mistake. Okay, so after that we can go for the another comparison. Here we are having the combinations as 0 to 810, and if 0 to 810 is occurs, then automatically there may be a chance of 08 to 10, occurrence of 08 to 10. And the next level comparisons is made here. And in the column 3, that is the second level reduction, the minterms are combined. What are the groups that are combined that have to be marked in the first level reduction? That is, what are the groups we are combining in column 3 that have to be marked in column 2? Okay, that is marked here, tick mark is given here. So the meaning is that the combinations which are grouped in column 3, that is in second level reduction, the combinations from first level reductions grouped in second level reductions or marked in this first level reduction. Okay, so don't get confused. Column 2 is first level reduction and column 3 is second level reduction. So here this have to be marked. So why we are marking this? So this helps in forming the prime implicant table. So we will see how the prime implicant table is formed in the next coming slides. Here is a definition of prime implicant. Given a function of f of n variables, a product term p is an implicant of f if and only if for every combination of values of the n variables for which p equal to 1, f is also equal to 1. Every minterm of f is an implicant of f. Any term formed by combining two or more minterms is an implicant. If f is written in SOP form, every product term is an implicant. All the product term given in the uh, table or in the reduction terms are considered as the implicant. So here is an example we can say. So here the terms, product terms a dash, b dash, c dash is equal to 1, then f is equal to 1. If a, c is equal to 1, then f is equal to 1. So that we can say a dash, b dash, c dash and ac are implicants. And if bc equal to 1 but a equal to 0, so that we can say f is equal to 0. So bc is not an implicant of the Boolean function. Next is the definition of prime implicant. So a prime implicant of a function f is a product term implicant which is no longer an implicant if any literal is deleted from it. So each prime implicant of a function has a minimum number of literals that no more literals can be eliminated from it or by combining it with other terms. So in what is the procedure for Quine Mc-Cluskey method? So first, the procedure is find all product term implicants of the function, combine non-prime implicants, the remaining terms are prime implicants. A minimum SOP expression, SOP sum of product expression, consists of a sum of some, not necessarily all, of the prime implicants of that function. We need to select a minimum set of prime implicants. If a sum of product expression contain a term which is not a prime implicant, the SOP cannot be minimum. So this is the next step is the prime implicant chart. So here we have to form the chart layout. So top row list minimum min terms of the function. So this is the top row, so which consists of the min terms given in the Boolean function, and all prime implicants are listed on the left side. So the thing we have derived in the column 3 and column 2, which we have discussed in the previous slides. So that have to be considered as the that are the prime implicants that should be listed on the left side, and place a cross mark or place an X mark into the chart according to the min term that form the corresponding prime implicant. And what are the essential prime implicant? If a min term is covered only by one prime implicant, that prime implicant is called essential prime implicant. Here, the min terms 9 and 14 are said to be the essential prime implicant because it is covered by only one prime implicant. So the min term 9 and 14 are said to be the essential prime implicant. That is the terms b dash, c dash, and here the c d dash is said to be the essential prime implicant. So essential prime implicant must be included in the minimum sum of the function. And selection of prime implicants, cross out the row of the selected essential prime implicant. So first we want to list out the min terms, and we have to write the prime implicants which are derived from the first level reduction and the second level reduction, and we have to mark the cross in the min terms, the what are all the min terms occurring that have to be crossed. And it is cross out the row of the selected essential prime implicants, and the columns which correspond to the min term covered by the selected prime implicants are also crossed out. Select a prime implicant that covers the remaining column. This prime implicant is not essential. So it will be very easy to understand, which will be which is going to be discussed with the help of a problem. So what the thing discussed is here is, so we have to mark the cross mark for the min terms here, and after marking that we have to consider the column which consists of only one cross mark. So uh, in in the problem it is considered as tick mark. I am going to discuss a problem. In that problem, this cross mark is considered as tick mark. So here the column which consists of only one cross mark have to be and the which min term that column belongs to which min term have to be marked as tick mark here. So that is the prime implicant. And we have finally we have to write the Boolean function by combining all the min terms. All the min terms have to be included while writing the minimized Boolean function. So we'll discuss with the problem. We are going to see a problem here. I'll show you the problem. So I'm working out the problem with a PDF editor. So this is the problem. Actually, there is some limitations of KMAP, so that we are moving to the what we are discussing. That is the Quine Mc-Cluskey method, tabular method. There are some limitations, so that we are moving to the uh, Quine Mc-Cluskey method. So the map method does not exceed 5 or 6 variable. We can able to solve with only 5 or 6 variables. If more than that variable occurs, then it cannot be processed with that Karnaugh map. So that we are moving to the uh, tabulation method. So as the number of variables increases, it is difficult to make judgments about which combinations form the minimum expression. So in case of complex problem with 7, 8 or even 10 variables, it is almost an impossible task to simplify expression by mapping methods. So K-map simplification is manual technique, and simplification process is heavily depends on human abilities. So we have to work out, and it takes lot of time. So to meet this need, Quine Mc-Cluskey developed an exact tabular method to simplify the Boolean expression. So this method is called Quine Mc-Cluskey or tabular method. So we will discuss a problem. Simplify the following Boolean function by using a Quine Mc-Cluskey method. F is equal to summation of 0, 2, 3, 6, 7, 8, 10, 12, 13. So as we discussed in the presentation, we have to group the minterms with respect to the number of ones. So the minterms are written here, and the binary representation for the minterms are written over here. So m naught is all zeros. So we are representing it with 4-bit, because the given Boolean function is a 4 variable function. So it is enough to represent with 4-bit. Right, all the minterms are written here by the minterms has been grouped with respect to the number of ones. So this is group 0, all zeros. Next is group 1. Here is number of ones are 2, and this is group 2, number of ones are 3, sorry, 2, and this is group 3. Here the number of ones are 3. Okay, so after that we have to go with the first level reduction. First level reduction, we have to compare the adjacent groups. So that is, the group 0 is compared with group 1. So in what way we have to compare? There should be a difference in only 1-bit position. Right, so here 0 comma 2 are grouped, and then 0 8 are grouped, and next adjacent groups 2 and 3 are grouped, 2 6 are grouped, 2 10, 8 10, 8 12. And similarly the last two adjacent groups are compared, that is 3 7, 6 7, 12 13. Right, so after doing this first level reduction, so in the presentation we have discussed this as column 1, right, sorry, column 2. This is discussed as column 2. And after completing this first level reduction, we are moving to the second level reduction. So in this second level reduction also, we are doing the comparison as done in the first level reduction. And in we have to include one more thing, that is, we have to check with the hyphen. The hyphen should occurs at the same position, and there should be a change in only 1-bit position. So which are all the combinations? 0 to 810. 0 to 810, here the hyphen occurs at third bit. Here also the hyphen occurs at third bit, and there is a difference in only 1-bit position. So we can make a group of 0 to 810. Okay, so if we are having a group 0 to 18, then there will be an automatic combination of 08 to 10. That is also same thing. And next comparison, 2 3 6 7. So first group and second group is there is only one combination, and the next one is 2 3 and 6 7. That is the group, second group and third group are compared here. 2 3 6 7. 2 3 is hyphen occurs at fourth bit position. Here also hyphen occurs at fourth bit position, and there is a difference in only one bit position. Second bit position differs. Okay, so we can write the values as 0 hyphen 1 hyphen. Okay, if you are having the combination as 2 3 6 7, then automatically there is another combination occurs, that is 2 6 3 7. Okay, so uh, with this, the second level reduction is over. The remaining combinations we can't able to group. For example, for 8 12 and 12 13, is there any possibility? So it is not possible because the hyphen is at second position in 8 comma 12 combination, whereas for 12 comma 13 combination the hyphen occurs at fourth bit position. So there will not be a combination of these two things, so it is not possible. So so what are the combinations we are making in second level that have to be marked as tick mark in the first level reduction? Okay, so here 0 to 810 is combined, so 0 2 is ticked, 810 is ticked, and another combination 8 to 2 0 8 to 10, uh, 0 first combination is 0 to 810, that is marked here, marked as tick mark, and 0 8 0 8 to 10 is marked here. Similarly 2 3 6 7, 2 3 is marked here and 6 7 is marked here. And for another combination 2 6 3 7, 2 6 is marked here, marking with tick mark, and 6 7 is marked here. Okay, so why we are marking this as marking this tick mark? This marking will helps in doing our prime implicant table, forming our prime implicant table. So after completing this reductions, first level reduction and second level reduction, we have to form the prime implicant table. So for forming prime implicant table, we have to list out the minterms given in the Boolean function. It is listed in the first row, and we have to write the uh, prime implicants which are all obtained in the second level reduction. That is obtained in the second level reduction is written as it is. So here 0 to 8 10 and 0 8 to 10. So this gives us the term as same thing. So here for these two things, so if you are having the variable a here and b, and this is C and this is D. So what is the term we can represent for this? Sorry, this is only D. Okay. Okay. So this A column is, we don't have any value here, and for C column we don't have any value. For B and D it is represented as 0. So if it is represented as 0, we can write it as B dash. For B it is B dash, B column, and for D column it is represented as D dash, right? And this can be considered only once. So this is written here, B dash D dash is written here, and the minterms, that group can also be written here. And the next one 2 3 6 7, it is A dash C. So A dash C, it is written here with the minterm combinations. Okay, right? So what is the thing we are returning here? So this is the term which are not marked in first level reduction have to be considered in the prime implicant table. So which are all the term not marked here, 8 comma 12 and 12 comma 13. This is not marked here. So this have to be considered in this prime implicant table. So 8 comma 12, 12 comma 13 is considered. For 8 comma 12 we can write the term as A C dash D dash. See here, A C dash D dash is written, and for 12 comma 13 it is A B C dash. 12 comma 13 it is A B C dash. So it is written like that, like this. And after writing the uh, terms, implicant terms on the left hand side, so after that we have to mark the tick mark. In the presentation we have discussed it as cross mark, so we can follow either cross mark or tick mark. So how it is marked as tick here? So for the min terms 8 comma 12, for this product term we are having the min term 8 comma 12. So this is 8, this is 12, it is marked as tick. And the next product term 12 comma 13, so for M12 and M13 it is marked as tick. And the next term B dash D dash, it is the combination with the min term 0 to 8 10. So 0 to 8 10, it is marked here, right? And for the next term A dash C 2637, so 2637, it is marked as tick here. So after marking the tick mark, so we have to make the or we have to consider the columns which are all having only one tick mark. See here, so this M0 column is having only one tick mark, so we can make a mark here. And M3 is having only one tick mark, here we are making a mark here, tick mark here. For M6 also, M7, and M10, M13, right? So what are the columns which are having only one tick mark have to be considered here. And for the remaining one, for M2, it does consist of two tick marks. So we should not consider this column, or we should not consider about this, about the minterm M2. And for M8 also, we are having two tick marks. We should not consider this. And M12, it consists of two tick marks, so we should not consider. So we have to consider the columns, or we have to consider the minterm which are having only one tick mark. Okay, so after considering this, so we are having a tick mark for M0. So go and search with the uh, product terms which is having the min term 0. So here is the min term 0. So we can make a mark here. So this is the product term which is going to be considered for our boolean function, minimized boolean function. We are going to consider this. Okay, and M3 where it occurs, so in this min term it occurs, 3 is occurs. Okay, so we have to mark this min term, this term is also be this product term is going to be considered for our boolean function. Okay, and M6 is where it occurs here, so it is already considered. Okay, and 7, so it occurs here, it is already considered. And M10 where it occurs, so it occurs in this product term, so it is also already considered. And in the last min term is M13, it is considered here, right? So we can conclude that these three minterms are going to be the product term for our minimized boolean function. And before writing that, we have to check with these three uh, prime implicants in such a way that all the minterms have to be included in these three terms. Okay, so we have to check with this. So this 0 is occurred in this min term, 0 is occurred. And 2 is occurred here, so this also combined. And 3 is occurring in this product term, so it is also included. And 6 is coming here, so this is also going to be included. And 7 is again occurring in the same term, so it is also going to be combined, included. And 8 is here, so this is included in our minimized boolean function. And 10 is occurring here, so this is also going to be occurring in our boolean function. And for M12 it is occurring here, so it is already included. And for M13 it is included here. Okay, so all the minterms are occurring here. So with these three prime implicants, or with these three product terms, all the min terms have been included. So we can write the Boolean function as f is equal to a b c dash plus b dash d dash plus a dash c. Okay, so this is the minimized Boolean function. So this minimized Boolean function is found out with the help of the Quine Mc-Cluskey method, otherwise called as tabulation method. Okay, so this is the procedure we have to follow if the Boolean function is like this. So see here, this Boolean function does not have any don't care terms. This Boolean function does not have any don't care terms. Okay, so in the next video we will discuss about how we have to do this problem if the Boolean function is consist of the don't care term. See here, this is a don't care term, and another example, this one, this is a don't care term. Okay, so we will discuss in the next video about this example. Thank you.